Okay, so we have another problem here where there's radicals all over the place. There's 2 in the numerator and 2 in the denominator. Now, if you were thinking, hey, could I just cancel the square root of p's and could I cancel the square root of 2's? No, because you have addition in the numerator and you have subtraction in the denominator, and so you don't have multiplication. You can only cancel factors. So the overall operation in the numerator is addition and the overall operation in the denominator is subtraction. So you can't do any canceling. If they'd been exactly the same, but they're not. One's a plus and one's a minus. Okay, so we're going to use the concept that we've been using. We're going to multiply by the conjugate to rationalize the denominator. So I'm going to rewrite this expression. The square root of p plus the square root of 2 over the square root of p minus the square root of 2. And then I'm going to look at the denominator and I'm going to multiply by the conjugate, which is going to be the square root of p plus the square root of 2. Now you might notice that that's the same as the numerator. That doesn't really matter so much. Okay, so we're just going to rewrite this up here because we have to multiply both the numerator and the denominator by whatever we choose to multiply by. And in this case, we're using the conjugate. Okay, so now we're going to go over here and I would multiply out the numerator. So I would go square root of p times the square root of p. Square root of p squared. And then I'll simplify it on the next one. So I'm going to use FOIL. Square root of p times the square root of 2. That's going to be plus the square root of 2p. And then I'm going to do this square root 2 times the square root of p, which is also going to be plus the square root of 2p. And then finally I'd do the last, the square root of 2 times the square root of 2, which is going to be plus the square root of 4. And then I'll simplify that later. Over, now I'm going to do the denominator. So the square root of p times the square root of p, square root of p squared. Then I have the square root of p times the square root of 2, which is plus the square root of 2p. Then I have negative square root 2 times the square root of p, which is going to be a negative square root of 2p. And then finally, I'm going to have a negative square root 2 times the square root of 2, which is going to be minus the square root of 4. Okay, so a lot of multiplying there because you're foiling the numerator, you're foiling the denominator. Now we just have to simplify it and we'll see what we get. So, let's see, another color. Well, I don't have that. Square root of p squared, that's just p. Now I have the square root of 2p, and I have another square root of 2p. So 1 plus 1 is 2. So that's 2 square root 2p. Those are like radicals. Those got to be combined. Plus, and then what's the square root of 4? 2. So I would probably just leave it like that in the numerator. The denominator then, square root of p squared, that's p. Then you have the square root of 2p minus the square root of 2p. Those cancel out. Those add up to 0. And then you have minus the square root of 4, or minus 2. So I didn't write it very neatly, but that would be the answer. Let me rewrite it. P plus 2 times the square root of 2p plus 2 all over p minus 2. And that would be the answer. You can't do any canceling because of the addition going on. So if you're looking at those p's, no, they can't cancel because it's p plus 2 times the square root of 2p. And now you might be saying, but they're both outside of the radical. Yeah, but it has to do with the addition. Now, if you didn't multiply out the numerator, you could have left it, it was the square root of p plus the square root of 2 squared over p minus 2. You could have left it that way. I don't think they're going to, though. I think they're going to multiply out the numerator. Okay, they take a little bit of work, but that's rationalizing the denominators.